Cool, thanks. I'm Sean Burnett. I'm a science team member on the Lunar Reconnaissance Orbiter camera, and today I'm here to present LROC NAC candidate Artemis 3 landing site control mosaics. Next slide, please. So just a little bit of overview. The LROC team is developing 1 meter per pixel scale NAC control mosaics covering all 13 Artemis 3 candidate landing sites to support future missions to the South Pole. The LROC NAC control mosaics are recommended in the Artemis 3 Science Definition Team report for accurate landing and localization during operations. Here we present our procedure for mosaic production, availability of products, and plans for future mission support. Just a note that overlapping sites were combined to create more seamless products. So like the degirl trims were combined into one mosaic. Yeah, next slide, please. So first I'm going to walk through the steps of mosaic production. So 4 main steps: image selection, image ordering, lighting optimization for maximum illuminated terrain coverage, and map projection and image-to-image registration. And then to the right is the current version of the controlled mosaic of the Malapert Massif site. Next slide, please. So for image selection, we chose to manually select images to maximize the total area of illuminated terrain, as opposed to more automated methods that sometimes create more misleading morphologies. And while the lighting geometry is still not uniform throughout the mosaic, we hope it balances interpretability with illuminated terrain. The images were segmented into low-resolution sections to minimize file sizes and null data and allow us to only use illuminated portions for each image. We used QGIS to select similar lighting geometries via subsolar longitude to minimize differences in lighting direction and determine the optimal image ordering. And then we used PSR and average sun visibility maps to assist with identifying areas that may not have had illuminated coverage or available data. The average number of NAC images used per mosaic were about 300, which turned into about 650 image segments. Next slide, please. And then for image ordering, so we did a first pass of mosaicing where we masked out the shadows with I/F values less than 0.0025 in each NAC. This was to maximize illuminated terrain, and as you can see in the figures to the left, so on the left side you have the unmasked version of the mosaic with none of the shadows masked out, and then the center is the masked version, and then the right is the masked version over the unmasked version to sort of fill in the gaps with actual data. We used ISIS 3 AutoMOS to mosaic the products, and we determined the order by comparing images with similar lighting based on subsolar longitudes. And while this first pass helped eliminate shadows, it left a lot of visible seams that were a bit unsightly. So next slide, please. So our next step that we are currently working on is a second pass to build a more seamless mosaic. We used composite mosaics of the images from the previous step with similar lighting geometries based on the subsolar longitudes and 10-degree bins. We mosaiced those into sub-mosaics and then used Photoshop to mask along the boundaries between images. Where possible, the boundaries were chosen based on lines of similar brightness between sub-mosaics. This was mostly to minimize seams and was using the lighten tool in Photoshop to find where the image is matched up closely. Could you go back for a second? So each color on the left is a different submosaic based on the 10-degree bins for subsolar longitude. Next slide, please. And then for map projection and image-to-image registration, the offsets were calculated from Wagner et al.'s automated control network and applied to each image. It was tied to the Lola topologic reference frame, and the offsets have been calculated to align nearly all of the images poleward of 84 degrees. They're aligned to within 5 meters of true position and to within about less than 10 meters at image-to-image scenes. For images without calculated offsets, we found average offsets using any aligned images in the same spacecraft orbit. The segments were map projected using the Lunar South Pole stereographic projection at a native image resolution of 1 meter per pixel. And then to the right is a GIF of 66 images post-control. As you can see, there's not much movement there. It's pretty well aligned. And the grid lines are at 150 meters per hour. Next slide, please. And for the scientific applications of the controlled mosaics products are possible morphologic investigations, photometric analysis, crater counting studies, hazard assessment for traverses and landing ellipses. And then to the right, we have some contours, some terrain products overlaid on the Malapert Massif mosaic. Next slide, please. Okay, so where to access the data products? So on QuickMap, there is the Malapert Massif is the first one done. We're still working on the remaining 12. They should be up on QuickMap by early May. Next slide, please. And then they're also available on the LROC PDS. The Malapert Massif combined 1 meter per pixel NAT control mosaic was recently released overnight, I believe, and is available at that link, as well as 1 meter per pixel companion subsolar longitude mosaics, which were the ones used in Photoshop to optimize the lighting a bit more. Those are also available, and all candidate landing sites and companion mosaics should be out in mid-May on the PDS. Next slide. And then for future work, we plan to release LROC NAT control mosaics of the remaining 12 Artemis 3 candidate landing sites to the PDS and QuickMap, as well as the companion mosaics. And we may have a LROC NAC DTM of Malapert Massif coming soon. Next slide. I think that's it. All right, thank you.
Yeah, thank you so much. It looks like there's already one question for you in the chat, but you do have some time if maybe there's a few questions you'd like to answer in real time. The one in the chat here, I'll read it for you, is were there any photometric corrections done to match the overall brightness of the images used in mosaicing?
There was some photometric correction done during the process of the image selection, I believe. I'm not entirely sure on what exactly that entailed, but we did correct for some brightness to try to get more what's the word? Consistent lighting throughout the images.
And then Ben Boatwright in chat asks if you were planning to generate NAC DTMs for any of the other regions beyond Malapert.
I'm not sure as of now, but I would not be surprised if the answer was yes.
All right. If there are any more questions, feel free to either raise your hand real quick or type them in the chat. And Sean, are you able to hang around a few minutes? Oh, now there's lots of chat. Okay. One clarification about the regional mosaics. Which ones are being released in May?
So the Malapert Massif one was the first one he finished that is out now, and by May we should have all 13 released by May.
Okay, and I see that Madeline's in the chat too. It can help answer any more questions as well. If you don't mind though, I think I'd like to go to the next presentation, try to get us a little time back. But thank you so much for the talk. It's really great.
Thank you.